Okay. Hi, everyone. Well, we are here today to present the InstantX initiative in the open source project that we are working. So first, we are going to review the content of the presentation. So we are going to make a quick introduction. Later, we will show the architecture of the platform. Then we will deep into the composition of how we build and how we are planning the development of the platform, and then we will review some real-time distribution messages that we can afford with this platform. Finally, we will provide an overview of the data ecosystem that we can manage with this project. And finally, we will show some vulnerable road user examples that we can provide with the platform. So first of all, who we are. So I'm Ruben Gil. I have near 20 years of experience in IT projects. We are based in Malaga in the Vodafone Innovation Campus. So I've been working there for almost 2.5 years. And currently I have the position of team lead and Scrum Master in the connected mobility projects. And she's Mar.
Yeah, hello, good morning, everyone. I'm Mar Hernandez. I am a Senior Manager Technology Product in the connected mobility area, and with more than 10 years of experience in different areas of IT projects, and now more focused on products and engage with this new open source opportunity here. And from Vodafone, we were collaborating with the Linux Foundation in some Open Run projects before as a telecom company, and now we are engaged with the Linux Foundation Edge with this opportunity. So we want to show you today what is InstantX. So we would like to introduce you our new open source initiative. The name is InstantX, is instant exchange of data, and the key is the data exchange in real time. How are we doing this? Well, we are using the cloud and the edge and exchanging the different messages in real time. How are we doing this? Well, we are trying to start with the communication V2X here, because we are just so close to the connected mobility in Vodafone, and we have the expertise in this area. But we want to have InstantX to collaborate in different areas, not just the connected mobility one. So now we are starting distributing HC messages, the European standard here, but we would like to grow and send different type of messages in the different areas, not just this one. But for the discovery today, we are introducing you this project, this opportunity, and talking most of the connected mobility area. So we would like to show where are they. So we are here in the service provider edge. Sorry, in the right side, and between the application and infrastructure part, a little bit more on the application side, but in the infra as well. And now Ruben is going to give you more details about the architecture, the current one, the plans that we have, and short, medium, and long term, and so on.
Okay.
Thank you.
Thank you, Mar. Okay, so as Mar says, in the next 3 slides, we are going to present the planned evolution of the platform. So in this one, we have the current architecture. So we can think on this slide as if it were divided into parts. The left side is like the big picture about how it is going to be deployed in different areas and so on. And the right one are the components that are going to be included in each site. So in an infrastructure point of view, we will have a main site where we can deploy all the components or only a part of them, and the edge site that we can put a different setup in different locations, just to ensure that we focus the platform to the utility that we want to give in those locations. So in the first stage, the one that is currently in our repository, we have a broker that is built with -q, and this broker is used to receive standard messages from other platform, and it allows a big amount of data processing. Also, we have the observability module using Grafana and Prometheus. And well, Prometheus creates some metrics or generates some metrics regarding the messages that we are receiving, and they are shown in graph using Grafana. So this is what we currently have in the repository, and in the next slide we can see the next step. In the next step, we are including the data provider capability. So in this case, a part of receiving the data from other platform, we are able to receive data directly from the data providers. So to allow that we have included the NiFi integrator framework that is able to receive messages in different formats and different protocols. So it is not using the ETSI standards. So NiFi has transformation capabilities, decoding capabilities, and it is able to send the -q through the Kafka that we also included in this version to communicate between different components. And also in this stage, we have also added HTTP protocol just to ensure that we make that platform human readable. So it's any human can send an XML in a readable format. So it is also open to this kind of uses. So we can do that. And in the future, what we want to add is also data storage capabilities. So doing that, we will allow to have more statistics about the amount of messages that we are receiving and processing. And also we will enable some machine learning insights based on the data that has been processed. And this is not the final architecture, so we can include more things and more components just to make it more flexible and give more powerful to the project. And also I want to highlight again that in any edge site we can have different setup of the components just to focus them to the data providers or the end user, or also the other platforms. And in this one, also remark that we have passed from Dockers to Kubernetes just to follow the microservice approach. So now in this slide, we can see the full picture of how it works. So as I said, we have different flows. So in the upper part, we have the data flow coming from other other platform. So this interaction is done through -q using the MQTT protocol, and this is in charge of distributing all the messages based on the geolocalization of the devices. So in this case, we have also a Redis adapter here that is containing all the configuration and all the subscription that each user is subscribed. So using that configuration, the event processor that is written in Python is able to select only the messages that the user wants to receive. And then with these messages already filtered using Kafka, they are sent to the message dispatcher that is written in Python, and it is published through MQP or HTTP protocol. Also, as mentioned in the second stage, we have a capability to use the data providers that are external system that using the AMQP protocol through the data flow management in NiFi, it can convert and process the messages that are not in a standard format and convert it into ETSI. So after that, using Kafka, they are sent to the MQTT broker, and it follows the same flow that I described previously. And the same happens with the end user with the HTTP protocol. that receive the messages through the event publisher written in Python and following the rest of the flow. Finally, the Grafana and Prometheus tools are in the upper part, just to see graph and statistics about what we have. And this is a very, very quick summary of everything that I have tell in the previous slides. So we have 3 stages: the current one, short term, and medium and long term. So in the current one, we have message distribution based on geohash, just to ensure that only the messages that are around you are received. So you are not receiving things that are kilometers away. We have dashboard with the messages that has been processed. And to do that, we are using HiveMQ, Grafana, and Prometheus. In the short term, we will enable the data providers to be able to send the data. Also, we will have capabilities to make the message transformation, and we will add more compatibility with different protocols, not only MQTT. And at that time, we can distribute the messages in Etsy. So it means that if we are receiving a message from a data provider that is not following the standard, we are able to convert it to the Etsy standard and publish that and distribute that to the rest of the user using the standard. So in any device that is following this kind of standards is able to receive the message. And the human-oriented interface protocol is what I mentioned, that we are able to send a text XML just to make some tests or to make it more human-oriented. And to do that, we are using, as mentioned before, NiFi, Kafka, Python, and Redis. And in the next stage, the medium and long term, we will enable the storage capabilities. And with that, we will have the metrics and analytics insights, and also we will allow the machine learning. And finally, but most important is we will enable this to work with another domain. So at this moment, we are more or less focusing in the connected mobility, but it can be used in other areas like drones or farms, agriculture, and so on. And this is done adding the Kubernetes, Spring Boot, and the data storage capabilities. And in the next slide, Mari is going to present some uses that we can do or we can have with this platform.
Okay, so what can we get in InstantX? For example, in real time. We are talking today about hazard warnings, distributed, and the kind of messages that we are supporting right now with the standard Etsy. And we are supporting the hazard warning for sure, but some of this, as an example, that we have here around the accident, weather condition, traffic jam, roadworks, and a lot of different messages here, and many more. This is just a couple of examples, but here we need to highlight that we are more focused in the vulnerable road user protection, because we think that this is key here to protect at the end human lives. So it is because we are orienting this kind of messages to this protection, to the safety at the end. All of them, but especially the key here is that we can as well be focused on the human part. And we have as well the data coming from different vulnerable users, but from the different vehicles as well, from the infrastructure, the different road authorities, a different data source in different formats. And this is a big pain, I can say, because you need to transfer this kind of messages, because we are confronting here the problem of the fragmentation, as you probably know. So another role for this InstantX project is to be able to aggregate sources and try to fix this problem as well. So we have a lot of different data sources. So we are aggregating, we can aggregate different sources because we can connect with road operators and infrastructure providers, road authorities, and providing real-time info about the different roadworks, speed advice, traffic lights, for example. And we are able also to increase the awareness of roadworks, optimizing the traffic flow, but not just the road work, as well about the road worker protection if the user is on the road. So with this, we are increasing the safety at the end. We are able as well to connect with the emergency vehicles, directly with the vehicle, with different devices inside of the vehicle, but through the authorities as well from the control center and so on. So at the end, helping with the fragmentation and creating an ecosystem with a lot of value in the mobility sector, and not just for the user, also as well for the authorities here. And now Ruben is giving you some examples oriented to vulnerable road users on the road.
Thank you. Yeah, in this slide, we can see a couple of examples. So this is just two examples of everything that can be done in this. It is just to highlight the real-time capabilities. So vulnerable road users are one of the more dangerous in the, well, the ones that has more dangerous in the road, because cars and so on cannot see them maybe if there is fog or something like that. So in these two examples, in the first one we have a camera that is able to detect a pedestrian, and then when it is detected, it creates a message that is sent in real time to the InstantX platform, and it is distributed to the rest of the users that are in the road, so cars, trucks, or even authorities to control the traffic. So when the message is sent to InstantX, the platform distribute these V2X messages to all the people that are around, or the devices that are subscribed to this kind of messages. So in the HC standard, there are different message types. So depending on the one that each one is interested, it is received or not. And other possibilities in the second example is for cyclists. So this has two way of view that example. So the first one is the cyclist has a device, a mobile phone, for example, that is sending its location in real time to the InstantX platform, and then it tells all the other users that a bike is in the way. So it is very good because you can plan how to go around the cyclist and so on. And in the other way around, all the cars can send also their position to the InstantX platform, so they can send the position to the cyclist. So with a specific application, the cyclist can see and can be advised that a car is near him and there is a risk of collision. So it is very good because it's not only a smartphone, so it can have also smart glasses or something like that, just to have a warning and say, okay, a car is arriving and you need to be careful. And then we are going to pass to the next slide, that is about how to contribute with the project. I think that most of you already know how to contribute, so this is more or less the obvious. But contributing is not only this. Contributing is also translate what we have in the documentation, or open discussion, propose new things, propose improvement to the architecture that we are doing. So all these kind of things are proposal and contributions. The most obvious is if you have something that you want to improve and it cannot be done by anyone else, you can have a fork of the code. You can modify that, debug that, making the test, and finally make a pull request to upload the code to the repository. So contributing in the project is more than that, is even speaking about that and expand the knowledge about that. And finally, we want to thank you all for your attention, and I hope you like the presentation.
Yeah, and we would like to encourage you to take a look and for sure contribute if you are interested. You have here the GitHub link. We are sending the presentation for sure, and our LinkedIn accounts as well. You want to be connected. And if you have any questions, I think we have time.
Yes, good presentation. One thing I'm interested, you might not be working on this, but I'm wondering if there are references to sort of what's the security architecture for this? How do I know that someone who says there's roadwork is actually someone who's authorized to say that there's roadwork on this road as opposed to someone spoofing it, right? Is this part of this protocol, or is it part of the information distribution thing that you guys are building?
Yeah, good question. In fact, we're ready to answer that. Yes, it's a thing that we need to confront, but we are right now in an early stage. But yes, we are doing this for sure, and we need to be able to do the research about the message sign and so on. So a lot of work to be done here, but as we are in an early stage here, yes, we have this we have as well the enterprise product, and we are doing really big research here.
Okay, thank you.
Thank you.